Good afternoon. So this is the second video in a series of 3. I recommend you go watch the first one on just a little intro of statistics if you're not familiar with statistics at all. The second one we're going to look at measures of dispersion, and then the third one we're going to look at how to run a t-test. But to run a t-test you need to know how to run measures of dispersion, so we need to do that one first. What do I mean by measures of dispersion? This is how we measure how spread out our data points are. So the classic one is range, where we just have a list of numbers and we look at the biggest one and the smallest one and what's the difference between the two. Variance is a little bit more complicated than range. So with this one, we're going to find an average and figure out what the distance from each point is to that average. And then standard deviation is another step from the variance. It's the square root of variance. And this shows us how spread out all those points are from the mean in a slightly different way. So in this class, we're going to do variance. I don't do standard deviation in this class. If you take a stats course, this is a very important statistic and you will learn it. But variance is the one that we need to run a t-test, so that is the one we're going to learn today. This is not a statistics class. I am teaching statistics because you use stats in every single discipline, but I'm not expecting you to know all the things that a stats teacher would expect you to know. So range, it's pretty easy. We're taking our highest number and subtracting our lowest number from it. Right? So our range is 14. The problem with this is it only tells us the difference between this highest number and this lowest number. Now, that's fine when all the numbers are really close together, but if you notice, 76 is 4 numbers away from 80. That's quite a big difference compared to the rest of them. And 80 and 81 and 76 are like, that's a 5-6 digit gap here. So if all your points are really close together, range is helpful. But if all your points are really close together and you have this one down here, range is not so helpful. You can have a range that's based on some random error. So instead, we look at variance. So variance is, here's our points, and this line is the average. We're measuring the distance from that point to the average, and then we're averaging those distances. Another way of looking at that is if we have all of these points, we find the average of those points, and then we get a different color. And then we measure the distances to that average. Then we take the average of those distances. That's our variance. We're getting how far each point is from the mean on average. So now this is, if we have an outlier, if we have a point way down here and it's really far and we have a point really close, we're not measuring on average. This point sort of doesn't count so much because we have an average and more of those points are more accurate. That really gives us a more accurate idea of how dispersed our points are. Because if the points are all really far away, we're going to get a very different variance than if the points are all really, really close together. How do we calculate variance? This is a little bit more difficult because we have to get the mean of all those differences. So how we look at that is we're going to take each point, and xi means a point. So 80 is xi, 90 is xi, 88 is xi, each point. We're going to subtract the mean from that point. We're going to square them. We square them so that we get all positive numbers. Mathematicians like to make everything positive. And then we're going to add them together and divide by the number of numbers. So remember on the last page, we said that we're getting the average distance from the mean. So that's what this is doing. We're getting the distance from the mean, we're adding them up. This symbol means the sum of. So we're taking the distance from the mean, we're adding it up, and then we're dividing by the number of numbers. In math, you don't just divide by n. N is your sample size. Remember that from our last session? N is our sample size. In math, you don't just divide by the sample size, you divide by the sample size minus 1. We call that the degrees of freedom. So I went through that a little bit fast. So I'm going to go through it again. This symbol here means the sum of. That means we're going to add this bit to itself over and over again. So that's what we've done here. We've taken that and we've added it to itself, and we've added it to itself. How many times do we do that? Well, we have to use xi. Xi is each one of these points. There are 8 points, so we're adding it together 8 times. X bar is the mean. So I'm going to do another click here. So we're taking xi as each point. So we're taking 90, subtracting it from the mean. The mean is 85. I did this on the other one. These are the same 4-year-old red oak trees from the first video. And when we add up 90 plus 89 plus 89 plus 88 plus 87 plus 81 plus 80 plus 76, divide by 8, we get 85. That's the mean, the average. So we have to do this for every single point. So 90, 89, 89, 88, 87, 81, 80, and 76, all of which I subtract the mean and then I square it. And then I add all those numbers up and then I divide by n minus 1. N being the 8 points minus 1 for degrees of freedom. That's variance in a nutshell. Now, this sometimes can be a little much for my non-mathematicians, so I'm going to show you a slightly different way of doing this. Some people, this is a much easier way because it's going to go very step by step. So for my mathematicians, you don't have to do it this way. But the first thing we're going to do is we're going to take all of our data points and we're going to subtract the mean from them. So 680 was what we got when we added up all our data points, and when we divide that by 8, we get 85. When we do this, these are the numbers we get. 90 minus 85 is plus 5. 89 minus 85 is plus 4. 89 minus 85 plus 4, right? But when we get to 76 minus 85, that's negative 9. Because half of these are negative and half of these are positive, this usually, when we add them up, equals something very similar to 0. It might not be exactly 0 if you have decimals, but it'll be similar to 0 because we're getting all the differences. Mathematicians don't like negative numbers. So what we're going to do is we're going to square all these to get rid of those negative numbers. 5 times 5 is 25. 4 times 4 is 16. Negative 9 times negative 9 is 81. Negative 5 times negative 5 is 25. So these are all positive numbers. Once we get these positive numbers, we're going to add them up because that's what the variance is, right? We're finding the distance from the mean So we're finding the distances from the mean. That's what this is. These are the differences from the mean. And then we're getting the average distances from the mean. So we've taken these differences from the mean, we're squaring them so they're all positive, and then we're getting the average. So what is the total here? We need to find our sum, and we call it the sum of the squares because these are the squares and we're adding them up. So in a classroom, I would do this as a clicker question. It's, if you want to take a moment, pause this video and do the math yourself, you can. But our sum of squares is 192. So back here, here's our equation, right? S2 is the symbol for variance. We took all our numbers, we subtracted the mean from them, we squared them, and then we added them all up. We got 192. There are 8 points in our data set, minus 1, there's our 7. So same as this. We took each of our points, subtracted the mean, squared it, added them all up, right? 890 minus 85 was 5, we squared it to 25. We added these all up, we got 192, 8 minus 1 is 7. So again, if you want to pause the video and find out variance all on your own, you can. But 27.43 is what our variance is. Now you need to know this because our next video, when we find t-test, we're going to use this number, just like we used our average from our 4-year-old red oaks. Now, when you take that variance, S2 is our variance, S squared, when you square root it, you get the standard deviation. So the symbol for standard deviation is like this squiggly S, like this, sometimes written slightly differently. That's the symbol for standard deviation. This is why when we're finding variance, we're not square rooting, we're finding S2, because if we square root it, then we get the standard deviation. So for our example, when we square root our variance, we got 5.2. That's our standard deviation. Standard deviation tells you how far those values stray from the mean, because that's what the variance is telling you. So if you get a standard deviation of 1, that means all your data points are really, really close to the mean. You have a really tight data set. If you have a standard deviation of 2, you still have a pretty good data set. Most of your data, 95% of your data, is really tight. Anything over 3 and you're starting to have a really spread out data set. So our data set of 5 shows that we have a very spread out data set. Our data is not very tight at all. It means it's less robust. It's not considered as good a set of data for running statistics on. And the results we get from it won't be quite as reliable. That is as much as I want you guys to learn about standard deviation. I do not intend on testing you on standard deviation, but I do want you to get a basis for it so that when you go to other classes, you can understand what it is and why we use it, and understand why we're finding variance. So it's one of the ways we measure the variance, the dispersion of our data points. So you would use standard deviation in a biology class. If you had a graph and you have your averages like this, you would have bars showing how they varied. So a really big bar like this is showing your data set is all over the place. But a nice tight little bar is showing your data set's nice and tight. So this is a good situation and this is a bad situation. That's how we would use standard deviation. But again, I need you to know variance. That is the thing I need you to know for this course. I'm just going through standard deviation because it is an important statistic that you will use in the future.